Okay, section 6.4, and I'll just give you the title of it already. It's called rectangles. And you're like, rectangles? I knew all about rectangles when I was a little kid. Do you agree?
I got confused.
But I bet you don't know everything there is to know about rectangles, especially when you're a little kid and you first learned this. So let's draw something that is probably familiar to you. All right, I'm not trying to trick you or anything. What do you think that looks like right there?
Rectangle.
Yeah, it looks like a rectangle. But can we say specifically it's a rectangle right now?
Nope.
No, you can't. Okay. Now, before you walked in this door first day of class this year, if I would have shown you this, you could have said, "Yeah, that's a rectangle. I'm positive that's a rectangle. I've never seen a rectangle any better than that one. That's a rectangle." But now that we know a little bit about stuff, can we just say that that's a rectangle right now? No, we can't. We cannot say it's a rectangle, all right, because it hasn't told us anything. Now, I can say it's a what, though, without any shadow of a doubt? A quadrilateral. I can say it's a quadrilateral, but I can't say it's a rectangle right now. Let me just give you the definition, but I'm going to draw it in the picture. Okay, I'm not going to have you memorize a list of definitions. Aren't you glad I'm not one of those teachers that does that? Okay, makes you memorize all these vocab words. Yes? No? All right, if I don't get a good response, I'm going to make you memorize them. Okay. All right, so let's take a look. Here's the definition. The definition of a rectangle. It's a quadrilateral. All right, so far so good. We got a quadrilateral with 4 right angles. Everybody get that? So that means that's a right angle. That's a right angle. Here's my third one, and here's my fourth one. Now, right there, that's basically the definition of a rectangle. It's a quadrilateral with 4 right angles. Do we have a quadrilateral? Yes. Are all 4 angles right angles? Yes. So guess what this is now?
Rectangle.
Now I can say this is a rectangle. Okay? Let's go a little further with this. I haven't said anything about parallelograms, have I? As far as this rectangle is concerned. But now let's start thinking about it a little bit. Look what I have. I've got this angle is equal to this angle. So these are opposite angles and they're equal to each other. Agreed? Look at this angle and this one right here. They're opposite angles and they're equal to each other. What did we say about a quadrilateral that has both pairs of opposite angles equal to each other? What did we say it was? We said it's a parallelogram. Did I say parallel? I said parallelogram. I should have said if we have a quadrilateral with both pairs of opposite angles equal to each other, that means it's a what? It's a parallelogram. So guess what this thing is as well? As well as a rectangle, it's also a what? It's also a parallelogram. In fact, it's probably a parallelogram first before it's a rectangle, because a rectangle is kind of like a special type of parallelogram. In the next lesson we're going to do, I believe there's 2 more special types of parallelograms. So this is one of them. It's a rectangle. All right. So everything that's true, if it's a parallelogram, everything that's true about a parallelogram is also true about this rectangle. So if we said it's a parallelogram, what else must be true about it? By the definition of parallelogram, what must be true about the opposite sides? That's right. Both pairs of opposite sides are parallel. Okay? So that means any rectangle in the world, any rectangle that you draw, you know that the opposite sides, both pairs of opposite sides are parallel to each other. And they're also equal to each other. That's right. So let's mark that. So the opposite sides are equal to each other. You probably knew that already when you were a little kid, right? That both opposite sides were the same. Yeah. What else? Opposite angles are equal. That's pretty obvious, right? Because all the angles are equal. So the opposite angles are equal. Look what else is true. What was one of the other theorems about a parallelogram? What was true about the consecutive interior angles? They must be what? Yeah, give me the word, though. What's that?
Supplementary.
Supplementary. Right, supplementary. Now, in this case, they happen to be equal to each other. But they're both 90, so 90 and 90 is what? 180. So they are supplementary, aren't they? Look at the ones up here and up here. They're supplementary as well. So is everything true about a rectangle that's true about a parallelogram? Absolutely. What's the other thing that we're missing? Well, I've talked about some angles. What about the bisect? What's being bisected? The diagonals, right. The diagonals are being bisected. So look, I need some diagonals in here, don't I? So here's one diagonal, and here's another diagonal. Now, we already know something about diagonals. Okay, Connor, you already said it. What's true about the diagonals of a parallelogram? They bisect each other. So a rectangle is also a parallelogram, isn't it? So the diagonals on this thing do what? Bisect each other. But it goes a little beyond that. It goes a little beyond just bisecting. Let me move this up a little bit. Now take a look at it. Watch. I did this in the other class. Let's see if this makes any sense. I'm going to take this diagonal. I'm going to copy and paste it and put it down here. Okay? Now watch what I'm going to do. Trust me that this is what I'm doing. Okay? I'll go here and I'll hit transform and I'll hit reflect about the vertical axis. So really all I did was just I took this one. Let's do this instead of saying this one. We'll call this ABCD. I took BD, right? I copied, I pasted it, and then what did I do? Flipped it, okay? Just flipped it around to make it look like this. So this technically was the length of BD. Follow me? Okay. So now watch. What if I took this and I went like this? What's true about those two? They're the same length, okay? They're equal to each other. So what did I just do? I just kind of showed you graphically, right, with this little program, that this, that's not a point on it, this one right here, BD, is equal to what? AC. All right, so on a rectangle, is that true about every single parallelogram? No. All right, it's only true when that parallelogram is a what? Is a rectangle. That's right. Okay, that's only true. So we can say, let's write this down. All right, we can say, this is one of our theorems actually. We can say that the diagonals of a what? Rectangle are what? Equal or congruent, whatever you want to say. So we can say that the diagonals of a rectangle are congruent to each other. That's not necessarily true about every single parallelogram. It's only true when that parallelogram is a rectangle. You get it? All right? Because if I drew just a regular, normal, everyday parallelogram, these diagonals would not be equal to each other. But they would do what to each other? The diagonals do what to each other on a regular parallelogram? They bisect each other. Well, they're going to bisect each other here as well. Now remember, AC and BD are exactly the same, and they split each other in half. So if I take AC and it's split in half, then these two segments are equal to each other. Well, what must be true about these two segments? We'll call this P. What about DP and BP? They're equal to each other, but they're also equal to what? AP and CP. Exactly right. Think about that. Watch. Let's say DB right here, this whole thing. And let's do this in a different color. What looks different?
Hawaiian blue.
Hawaii. No, we already got a blue on there. Let's go purple.
Amethyst.
Amethyst. Where is that? Right there. Okay. Let's do this. This DB, that whole thing. Let's just say it's 10. I'm just making it up. Okay. Then if that's 10, what's AC gonna be?
10.
That's also gonna be 10. Now watch. Those diagonals are bisected, right? So if I take 10, split that in half, what do I get? 5. So AP is 5, and guess what else is? PC. Well, what must be true about DP and BP? They both have to be 5 as well. Okay? So look at those 4 segments that I've drawn right there. All 4 of those segments are equal to each other. You see that? All right? And the reason is because I took 2 equal lengths, right, the diagonals. I cut them both in half. So that means everything's going to be equal. Agreed? All right, so that's the reason. Got a little messy in there, but I think you get the idea. All right? What do you think of that? It's pretty interesting, isn't it? All right? And that's really the only thing that's different about rectangles. Basically 2 things. Basically, a rectangle is a parallelogram, but it's special. What's special about it? We'll say that's the second special part. The first one is, right, you have 4 right angles. Right, that's the first thing that's special about it. You have 4 right angles. What's the second thing that's special about the rectangle? The diagonals actually equal each other. Okay, so both diagonals are exactly the same. All the other stuff we know about it is true about every single parallelogram. But these 2 right here are special because it's just about a rectangle and not just a normal everyday parallelogram. You get it? Okay. I told you I could do this under 10 minutes. Look at that. You know what I'm going to do now? Well, I would have given you a worksheet today, but did everybody get that? I'll keep it up there. problem was the printer's been the copy machine's been messing up and it's been jamming like crazy, and so I did not. Don't get too excited. I didn't give you a worksheet, but I'm actually going to give you some problems from the book, which I don't normally do, but we'll get that book broken in a little bit and you can use it. So it's here it is. Write this down. So it's section 6.4, and it's pages 422 and 423. 422, 423, and we are doing. I'm breaking it down into two different sections. It's 10 to 19, and then we're going to go 22 to 25. 22 to 25. Okay? So page 422, 423, we're doing numbers 10 to 19 and 22 to 25. All. I think there's more in here I can give you if you want me to. Yeah, since you suggested the evens. Because if you suggest less than I give you, I have a tendency to want to give you more problems to do. Maybe that'll rethink you suggesting less problems. Okay. Alright, we good with this? Alright. So that'll give you something to do during your weekend, right? Alright. Remember, we're going to take a quiz on Monday. It was supposed to be today, but we had the snow day. So quiz on Monday, and just the first two sections, 6.1 and 6.2. Okay. Yes, all the chapter 6 is on YouTube. So if you want to look at the YouTube videos this weekend, that might be a good idea as well. All right. So you can get ready for 6.1 and 6.2. Everybody got that? Now remember, on 6.1, I believe, was that stuff about the exterior angles and some of the interior angles and all that stuff. So you may want to review that. I would really suggest that you do that. Okay. So so look those up on YouTube. That'll help you out. All right, that's enough. Have a good weekend.